Welcome back to Physics 30. This is the second part of the photoelectric effect investigation. So we looked a little bit at this, and I gave you some preamble that you need to know. But we need to find this investigation or this simulation. So if you go to Google and just simply type in, so PHET photoelectric effect and click on this. Because if we go to the PHET site, it doesn't show up. So what you have to do, Google search is PHET photoelectric effect. And because what's happened here is anything that is flash, of course, has been changed for this year. So there's some Java versions that are in the works. And so instead of clicking on this one, let's go down to here and click on Java version right there. And at the bottom of your computer may say, this may harm your computer. Do you want to keep it anyway? And it is yes, because this is a reputable site and it should be good. So at the very bottom left of your computer, it's likely downloading it. So what you can do is click on it and hopefully it opens up for you. So there we go. So if you see that, and here it is. Here it is. Okay. So we have this, and so part of the part here, it says move the slider to 100%. Does light have sufficient energy to dislodge electrons? So if we do that, here's the intensity bar, move it up, and you can see, oh, look at that, dislodging electrons. Okay. Also in the instructions, it talks about going into the options menu. Now, if you can't see that, that's just up here, and we want to show photons. So look at that, we're showing photons. And as we adjust the intensity, it changes things so you can describe. So each of these little circles here represents little particles of light coming down and hitting this metal plate. Okay? So you will be adjusting that and doing a couple of things where that's concerned. Also, we can make this 100% intense, 50%, so we can adjust that. Over here we can change it from sodium to zinc to copper or to unknown. I believe the whole investigation just involves using sodium, though, sodium metal. And of course we can adjust the wavelength here. So we can go increased wavelength, which of course is smaller frequency, or lower wavelength, which is higher frequency. Okay? So you're going to be doing a few things there. Also here, so right now we can see there's a current here, and you can see, oh, current means there's electrons flowing through the circle, because right now the battery is 0, so it's not causing a current. The dislodging of these electrons is causing a current. And of course, part of the simulation will involve manipulating this battery here. So if we slide it to the right, we can change the voltage and change it this way too. So I believe, and you can see the plates here. So if I move it this way, negative plate, positive plate. If I move it in the opposite direction, in effect I'm changing the direction of the battery to make this side negative. And of course, electrons going to a negative side, yeah, they don't want to do that. All right, so hopefully this makes sense. So running through the entire handout here. So this first page just involves playing around with this scenario. Over here, V equals lambda F. You figure out figure out the corresponding frequency. Having trouble finding my words. But remember, the universal wave equations uses wavelength in meters. So over here, when you get your wavelength, of course, all the wavelengths are in here are in nanometers. So you have to change that into meters. And of course, if you look at the last video, you can see how we did that. Okay, so there's a few manipulations you'll do when you get to number 8. Of course, we're going to use this electron volt equation here. So it's over here. And with this one, you can leave the lambda directly in nanometers. So it's a handy little equation to use. Leave it in nanometers, and you can figure out the energy in terms of electron volts. So there'll be a few calculations there. And some of it has to do with that, the energy of the photon. Some of it is used to dislodge electrons, and some of it is used for kinetic energy. So this simulation eventually leads to that, leads you through the process in which that happens. and it's going to involve manipulating that battery a little bit and going from there. So hopefully you should be able to do that. If you have any questions, of course, while doing this simulation, don't be shy. Just ask me, and I can hopefully clarify any of the questions, because it's a fairly big investigation here with 18 parts that you'll be doing. But it's not that difficult. And if you run into a snag, look at the previous video where I do where I look at the equation there, and hopefully you'll be able to do that. All right, we'll see you again.